Hello guys, welcome to another video of the Cheshire Dev channel, and today will be the second video of this series of solving Leetcode problems. And the second problem I'm going to solve is this, the valid anagram. I have to say that as the problem before, I had a solution in mind. This problem I solved it before, so this is kind of cheating, but anyways. So the problem says that given two strings s and t, return true if the two strings are anagrams of each other, otherwise return false. An anagram is a string that contains the exact same characters as another string, but the order of the characters can be different. The same characters and also the exact same amount of the characters, so to speak. My The first time I solved this, my first thought was to sort the two strings and then compare them in each position, in the same position, both of them. So the first time you'd find a different, you will return false or something like this. Let's say that we are using cat and we're using act. So I would sort them. Sorry. So this will stay here like that, and this one would become this. So then I would go to another function. I would send this to another function, and I will start asking, is this value the same as this one? So the two strings in the 0 index. If the answer is yes, I move on to the second index. Is this one the same as this one? Yes. Is this one the same as this one? Yes. And if we go to the end of the arrays without finding a difference, then we will return true. And let's say that instead of act, this was car. So now this would be like this. Sort after the sorting, and then I will do the same exact thing until this part where T and R are different. So I will return false. And that was my first approach, the first time I saw this problem. But there is another approach that is kind of clever, better than this one, which is maintaining the frequency of each character. So I'm going to explain this to you guys the way I understood this the first time I saw it, and we'll see if that makes sense for you. So I will try to explain it the best way I can. To first, we're gonna start. Okay, well, this means by saying that we maintain the frequency is that we're going to create an array of 26 positions, so to speak. 26 because of the alphabet, English alphabet in this case. So, and every time we find a character, we are going to increase the counter of that character in that array. So for example, let's say that we have again the same example with cat. So since we found C one time, so in that position of the array, we're going to increase the counter, so it would be 1. The same for A, the same for T. So there are a lot of things that we have to do before implementing this logic. The first thing is creating the array. So I'm gonna count array, and I did have to look this for, so it says 0 times 26. Okay, why initialize this in 0? Because the 0 value will tell us if this is an anagram or not. That will make sense later. So now we have a count array with 26 positions, all of them initialized as 0. And now we're going to so I made this kind of graphic here, and as you can see, this is the count array, 26 values initialized as 0. And to see, how can I say this? To determine the position of the found character in the array, we are going to do something that in Java it worked. I don't know if that's gonna work in Python, but here we have to see this concept of the ASCII table, especially the decimal value of a string or a character. So if we go here, we can see that the lowercase letters of the alphabet, they have their decimal value, right? So how are we going to find out where, in which position, in what position of this count array we are going to increase the counter? So here I already did this table to make it easier to see. So for example, the A will be in the 0 position, the B in the 1, and like that to the C letter. But how do we know that P is the 15th position of that C is the second position of the array? So we are going to use these values, and the way we are going to do this is that as we loop through the string, we are going to make a subtraction, and we are going to subtract the current letter that we are looping through minus the A, the value of A. Why A? Well, this will make sense later. So okay, how do I loop through a string? So for letter in S, so count array. So here is in Java we will do this, for example, letter minus A. So letter in this case, since this is a subtraction, it's, let's say for the cat example, so C in this case would be, let me look for it, would be 99, right? So C would be 99, and then we know that A is 97. Yeah, 97. So we are going to subtract 99 minus 97. That would give us the second position. 99 minus 97 is 2. So in the second position, we are going to increase the counter. So in this case, it will go from 0 to 1. You know, that's the logic behind this. So we are going to do that, and then we are going to do the same thing for the other array, the other string. But in this case, instead of adding to the counter, we are going to subtract from the counter. Why, you might be asking? So let's go back to the example of the cat and act. So let's say that we are the first S is equal, okay, S is equal to cat and T is equal to act. So we're gonna loop here and we're gonna say, okay, letter in S, so it's C. So the 99 position minus 97, in this case the C. So we are gonna find that that's 2, and we're gonna go here and we're gonna add 1. Then the second is A. So A minus A, that's 97 minus 97, that's gonna be 0. So we're gonna increase the 0 index. And then T is 116 minus 97, 116 minus 90, that's gonna be 26, minus 7, that's gonna be 19. So T is 19, so we're gonna increase 1. Okay, this is for the cat letter. So now, okay, now we're gonna go to the second loop. And we're gonna do the same for act. So okay, a minus a, that's 97. In this case we're gonna decrease. So okay, 97 minus 97 is 0. So the 0 position we decrease one value and it's 0. Then we go back and we go to C, and in this case it's gonna be 99 minus 97, so we decrease it, and then we go to the T and we do the same. So now, as you guys can see, the count array, all the values of the count array are in 0. This is gonna be important because this is how we will know that we are actually looking at an anagram. So we're gonna go for count array. Okay, for count array. So if the value is different than 0, we are going to return false, like that. Okay, false is with false, and I'm going to return true if that's not the case. So what's gonna happen, for example, when the two letters are not anagrams? So let's say that the second letter was a car, for example. So in the first loop, we are going to increase the values of C and A and T. So we're gonna do that. C is gonna be 1, A is gonna be 1, and T is gonna be 1. But now the second string is car, so we are going to decrease these three positions, right? So we're going to decrease C, that's gonna be 0. We're going to decrease A, that's gonna be 0. But now we are not going to decrease T because T is not in car. We are going to decrease R, and 0 minus 1, that's minus 1. So what's gonna happen when we go to this part of the code? We're gonna find that this position is different than 0, and this one is also different than 0. Now the loop will exit as soon as we find one, but anyways. So this value is different than 0. It means that this letter was found in one of the two arrays, but not in the other, and this one was never decreased. So it means that the letters were not exactly the same, and that's how we are going to determine if this is an anagram or not. So I think this is how it worked. So let me run this. We might find, yeah, what? Invalid. How are the comments in Python, by the way? I don't know. So okay, invalid syntax. Invalid syntax. Oh, how do I increase invalid syntax? This doesn't exist. Let me. So okay, so that's how you do it in Python. And this is minus equal 1. What? It says unsupported operand type S for a string in a string. Okay. Okay, so this is the first issue and it's the big one. Type S or minus. So how do I obtain this value right here? So let me say something later. No, this is print there. What am I even looping? Wait, yeah, R. So R, how do I get the decimal value of a string or a character? Let me see something. What if I type this directly like that? Yeah, the error is not this, the error is this. So let me see something here, I think. So this is very common in string problems like counting letters, index, ord. What is ord? What is ord? Ord, C minus ord. Okay. I'm gonna try that. I don't know what the wait a minute, but I need to. Okay, that's the index. Okay. So that's how you do it. Index is going to be equal to ord letter minus ord, and in this case it's a, and count array dot index is going to plus equal 1. So I'm gonna do the same for this, but in this case it will be minus. So okay, let me see. Okay, this works. This works. Okay, it says that, look, I don't know. I don't want to submit this because there is a validation that I noticed. What if the two strings, yeah, even if the two strings are of different length, I think the current implementation will catch that. Anyways, so there is no need to add that validation. I use lowercase. That I didn't say that because the description of the problem says that the words consist of lowercase English letters, so we don't need to validate the uppercase ones. And as I remember, this was kind of longer. I don't know what's missing. So we go to the first string, go to the second one. Okay, I'm not sure if it's gonna work. I think there was a validation. Okay, I skipped the first validation. Okay, anyways, even if the two strings are different lengths, this gotta work because yeah, they won't match anyway. So I'm gonna submit this. It worked. Okay, it worked. It worked. It went to this part of the graphic. So the runtime is fine. The memory is not that fine actually. It's 8 megabytes and this is 7. Okay, they are using a hash map. Yeah, this is the validation that I was talking about. And the length. Yeah, because if the length is different, we can skip all this process. We don't need to loop through the arrays because it won't be an anagram. Okay, this default dict is to create hash maps that are initialized. So char, and the index will be the character. Yeah, so every time you find this character, you increase the counter. Return. Oh, okay, look at this. Return s1 equal to. So if the two maps are equal, this will be true. If the two maps are different, this will be false. So this is a really cool approach actually. But anyway, guys, this was the second problem. At least runtime wise, it was good. But okay, I'm gonna stop the video here, and I'll see you guys in the next one.